Hi, and welcome to this video about sharing memory between processes using memory mapped files. So what are memory mapped files? These are known as section objects. This is the actual kernel object type within the Windows kernel. In user mode parlance, they're called memory mapped files, but these are the same ones. Their basic capability is to view files using memory semantics. That's why they're called memory mapped files. In fact, this is how executables and DLLs are mapped into memory when we're using DLLs and executables, which of course happens all the time. So we get a pointer, or at least we can get a pointer into memory directly without using I/O APIs. And there are several advantages to that, which we will not be covering in this video. What I would like to focus on this video is to show how we can share memory between multiple processes that might be running different executables by using memory mapped files. We've seen one simple way of sharing memory in an earlier video, but this required us to use the same executable or the same DLL. The more generic approach using memory mapped files is not restricted to using processes that are running the same executable or anything like that. It could be completely different executables. Don't we have to have any kind of relation with one another? So let's see what that looks like. So let's go with Visual Studio and create a new project. To make this slightly more interesting, I'm going to select a WTL application, a Windows template library application, to create some simple UI. WTL is my favorite library in order to use the classic Win32 UI. I'm going to call that shared mem. To get access to WTL, you can install it, just look for it. And one of the things it gives you is this nice wizard. And I'm going to select the simplest thing that I can, which is a modal dialog based application, and make sure that I do get C++ files to make it better modular and not having everything drop down into header files. And we can use finish here. That's going to be good enough. To get the actual WTL library, we actually have to install that using VC package or NuGet. So if you don't have that installed using VC package, you can always right click here the references, go to manage NuGet references, and then you can search for WTL. Once you search for it by going to browse here, you can go ahead and click install, and that would be installed for you in this project, and that's going to be all that you need. So now we have already a simple application here that has some code within it. So the first thing I want to do is to play around with the UI a little bit. So don't worry, it's not going to be something complex here. I'm going to go to the resource view. If you don't see the resource view by default, and probably you won't, you can go to the view menu, go to other windows, and look for the resources view. It will be here somewhere, right here. And then I'm going to double click the main dialog ID here to show the main dialog created for me by the wizard. I'm going to delete all these buttons, and I'm going to create a very simple UI that looks like this. So first we can customize the properties of this dialog by, say, changing the caption, something like this, like shared memory demo or something. And then we can go to the toolbox and grab a few controls. The first one is going to be an edit box here. So the edit box is going to be used as a location to put some text. This is what we're going to share. We're going to share text just for simplicity and to make it easier to see the shared part. And I'm going to add two buttons here. Here's one button. I'm going to provide the text as write and add another button, and I'm going to call here this button read in the text itself. Of course, we can play with the ideas, but I'm not going to do that to make it slightly easier, or at least faster to move along. I'm going to select these buttons and go to format, arrange buttons at the bottom just to make it nicer, and we can go ahead and actually go to the code, but maybe I will change the names here to make it easier to understand in the code. Let's call that IDC write, let's call that IDC read. Okay, so we have that, we can build, and we expect the application to build successfully. We didn't really write any code just yet, but it should still be fine. If I press Ctrl F5, we can see we get an instance of this executable running. Okay, great. So now what we want to do is to be able to run multiple instances of this executable and be able to share this text. And I'm using the same executable simply out of convenience. This would work with different executables as well. So let's see what that would look like. I'm going to go to the main dialog header file here. This is where I can initialize my dialog box instance stuff. So what we can do here is add a handle to the memory mapped file object. Let's call that mh shared mem. And then in the onInitDialog function, which is the function that's going to be used to run the initialization code for the dialog, there is some junk code here which is not very interesting. I'm going to create the file mapping object. So I'm going to call the function create file mapping. Let me just increase the font size here. And create file mapping allows me to create shared memory based on a file, a real file, which means we can have the data being persisted after all handles are being closed, or just use the page file for backup purposes, and once all handles are closed to the same file mapping object, all the data goes sort of down the drain. And we'll go with the latter approach in this video. So I'm going to select here invalid handle value as a way to indicate that I don't want any file to be associated with this shared memory or potentially shared memory. Then we have some security attributes I don't care about. We have protection, which I need to specify the protection I would like for this shared memory. We're going to use ReadWrite to be able to read and write to this memory. Then we can specify the size of the shared memory using two 32-bit values, which are combined to form a single 64-bit value. So in this case, I'm going to go with something relatively small, something like 1 megabyte. So here's going to be high byte, and then the low byte is going to be 1 megabyte by taking 1 and shifting that 20 bits to the left. That's 2 to the 20th power, which is exactly 1 megabyte. And for this demonstration, that's going to be big enough. And then we can give the file mapping object a name. This is the kernel object name, which is very useful for sharing purposes. So we'll give it some kind of name, say my shared memory. And that's going to be it for creating the object. Let me just add an assert here to make sure that this in fact works as I expect and get a non-null handle back. And now we can go ahead and implement the read and write capability. So we have these buttons here, which I'm not actually using explicitly, but let's just copy paste here what we want to actually get here. These are going to be the handlers for read and write. So I'm going to add an onRead function here and onWrite function here. And then we'll just add macros here to point to those handlers for these buttons. So it's going to be IDC write to call on write and IDC read to call on read. Like so. So now we need to implement these two functions. Let me just press Ctrl dot here to let Visual Studio help me out here. So we are in onWrite here. We need to perform this implementation. So what we have here is the file mapping object. That's nice, but we need something more in order to access the actual shared memory, which is mapping a view into that shared memory, which could be to the entire shared memory or just a part of it. And the way to do that is by calling the function map view of file. That's one of the ways to do that. So first we need to provide the shared memory object, that's the file mapping object. The actual mapping we'd like to use, in this case that's going to be a write mapping. And of course all these constants like I'm getting out of thin air, of course they're fully documented. I'm just already familiar with these values. And then we can specify where to start the mapping in terms of offset and what the size of the mapping should be. So let's begin at the beginning of the shared memory. So we have the 64-bit value again as 32-bit values attached together. And then let's take the size as something like, just for demonstration purposes, 64 kilobytes. So we have 64 kilobytes out of the 1 megabyte of memory that we can share. Now I'm looking with a view just for the first 64 kilobyte. That should be good enough. I'm not going to do any kind of error handling here except for just making sure this actually worked, and it should, because we're talking about very small amounts of memory here, so it shouldn't really be a problem. And now we can actually go ahead and write to this memory whatever we want. In this case, what we're going to do here is to grab the text from the dialog box. So there's a get DLG item text here that I can use, and we can use some kind of string like C-string, which I have to add include for, but let's make it easier just by defining some text here. Let's say 256 characters is going to be good enough. We need to go to IDC text, and we have here the name. We can provide the pointer to the string, and then how many bytes, or sorry, how many characters we can accommodate. So that's one way of doing that. And then we need to perform the actual copy. So we'll do WCS copy. We need to copy that to the actual memory. So to P, we need to copy text. but since it's well, actually that should be good enough, but just need to make the compiler happy by making it see the p here as a pointer to a string, because it's just a void pointer by default. Of course, nobody really knows what that is holding on to now, because the pointer p has no particular size that the compiler is aware of. We also have to make sure that indeed we don't have too many characters here. So in fact, count of text is going to be good enough for this purpose, and we should be good to go at this point. The last thing to do is to unmap the view. We don't need it anymore at this point. Of course, the memory itself, the shared memory, is going to be intact. There's no reason for this to go away because the shared memory object is still very much alive. So now let's go ahead and implement the last function here, which is on read. So I'm going to do some copy pasting here and then just change what needs to be changed. So first thing is to perform the mapping using read. I'm going to use the same offset and the same size, so I'll be able to access the same memory, of course. And then the last piece of the puzzle is to write this information into the edit box. So I'm going to use this function, setDLG item text, and grab the pointer p and just copy whatever it has into that as a string. And again, we need to make the compiler happy, so let's just cast that to a pointer to a constant string. And that's about it. Let's see if it works, and let's see what we see in Process Explorer while we're experimenting here. So I'm pressing Ctrl F5 here, so here's one instance. If I go to Process Explorer here and look for that particular process, so we're talking about this called shared memory something. We have one of those right now. So here's shared mem. And if I look at the list of handles here, I'm going to have a section here that has the name my shared memories. You can see here, it's always prefixed by the sessions1 base named objects prefix, which we, I think, mentioned in some other video. In any case, that would be the full name of the section object. If I double click this handle properties, we can see the properties of the object. There's just one handle to the object, which makes sense. We just have a single instance here. So let's see what happens when I press Ctrl F5 again to launch another instance. So here's another instance. Process Explorer is simply blocking it with the always on top setting here. So now we have these two instances. And at this point, if I go back to Process Explorer and double click the same exact handle, we can see there are two handles to that same object at this point, which is what we expect because now we have another shared mem instance here that has a handle to the same section object. It has the same name. The handle value might be different, but the name is the same. So let's see if sharing actually works. I'm going to grab one of these instances and write something like hello memory and press the write button. Then I'm going to press the read button or the other one. And here's that string right here. If I change it to something else and write from the second instance and read from the first instance, we see the same thing. And if I go back here and launch another instance, so here's a third instance which wasn't there to begin with, I'm just going to click read here, it's going to show exactly the same thing. So they're sharing this piece of memory, and the key here is the fact that we're using the same section object. That's the key here. Now we have three handles to the same section object. That's the important part, because if you have different section objects, they're just different pieces of memory and they're not going to be shared at all. So if I go ahead and close all these instances at this point, so everything is now gone, and if I press Ctrl F5 again to run another instance and press the read button, we get back nothing. And that's because the memory is not persisted after the object itself is destroyed, and we can think of that as being recycled in the page file, so to speak. We could have created a backup with a file, which is one of the options to create file mapping. In fact, that's the first parameter, which is something that we might do in a different video. Anyway, just to prove how important sharing here is in terms of that name, let's see what happens if I remove this my shared memory and replace that with a null pointer. So now I'm going to do that again, create two instances. We can create more, but two is going to be good enough to prove my point. So now I have these two instances. I'm going to write something here and press the write button. I'm going to read here, we get nothing. If I write something here and I go to read here, I get back nothing. Well, I get back the same thing that we see here. And the reason that there is no sharing here right now, because we have two separate section objects. If we have two separate section objects, it's different shared memory, so it's not really shared, it's just private to that process because it's not sharing that in any other way. It is possible to share by not using a name, but by a different mechanism, like handle duplication or process inheritance, but we're not doing that here, which means we have two separate section objects. If I go back to Process Explorer here, we won't be able to see the named object here because it is unnamed. We'll have to go and use show undem handles and mappings to see unnamed objects. So now we'll be able to find the section object here that we're using. It's not really easy to see either that is this one or this one. We can't really tell up front. In fact, we have to display the handle value in some way, but regardless, there's a single handle here. Just a single handle to this object, and for the other shared mem instance, the object is going to be different. It's going to have just a different one. And the way to compare that for sure is by looking at the address of the object. If it's a different address, and it is, in fact, then definitely it can't be the same object no matter what. So this is why we don't get any kind of sharing unless we perform sharing of the of the section object to begin with. Only then can we actually share memory that is being managed by this shared memory object or the section object. And one way of performing this kind of sharing by using a name. And that's why it's not restricted to a particular executable. I can have a different executable as long as it calls the same kind of code like this one. By using the same name, my shared memory, sharing is going to happen. So it doesn't really matter what executable is actually executing this code. I'm using the same executable here just for convenience. Any executable will do. So there you have it. This is a more generic way of sharing memory between processes without any special restrictions that we might have seen in a previous video related to simple memory sharing.